Hello everyone, so today we'll be going through some of the TYS questions. So let's take a look. Alright, so we'll start with question number 4. So different volumes of hydrochloric acid and silver nitrate were mixed and silver chloride was formed. So what you need to know is that all of the silver reacted with the hydrochloric acid. So you will get something like this. Silver nitrate, you must know that this Ag plus, this NO3 minus. So over here we have AgNO3 reacting with HCl to form AgCl, and then I guess there's an exchange, so it's HNO3. So what we can see is that actually 1:1. So the ratio need to be 1:1 to form 1 AgCl. So let's take a look at the different examples. So let's look at A first. So A, we see that both of them have the same concentration. So the volume means that the ratio of HCl is to NO3 is 1:1. Okay. The next one over here, we have both of the same concentration again. Okay, so that means we can compare the volumes. So now see, which one do I have more? I have more of the NO3. So if I have more of NO3 means I have too much of NO3. So actually, how much AgCl would be affected by this guy, right? For option A, it will be affected by either one. So it's 10 cm3. Let's look at the next one. We have 10 cm3 of 1 mole and 10 cm3 of 0.5. So if you compare the rest, we make it 10 cm3, 1 mole per dm cube. So this is equivalent to 5 cm3 of 1 mole per dm cube. Do you know why? Right? If this is like, let's say 50% sugar, right? And this is 100% sugar. Having 10 cm3 of 50% sugar is the same as having 5 cm3 of 100% sugar. So as you can see over here, the one that is lesser, right, would be the 5 cm3. Okay, and for this one, we have also the same 1 mole. This one is 0.5. So we'll do what we did the previous time. So this is the same as 12.5 cm3 of 1 mole per dm cube. So we can see which one has more. 12.5 will be the limiting reactant. So again, limiting reactant, limiting reactant, limiting reactant, and limiting reactant. So happens that all the HCl's are limiting reactants over here. So we want the greatest mass. So we just need to see which limiting reactant has the most. So the limiting reactant that has the most would be B. So for this guy, the answer would be B. Okay? Alright, next one, question number 6. So question number 6, this is an example. Please write down in your book, is what we call a thermometric titration. So in a thermometric titration, it's similar like titration, but we're looking at the maximum temperature, and at the maximum temperature, we will have neutralization. Please take this down. Okay, so the hydrochloric acid has a concentration of this. So let's write. So I got HCl, so C and V. So the C of HCl is 2 moles per dm cube. And then different volumes of acids were added and the maximum of each temperature. So what is the concentration of sodium hydroxide? So I need to find out NaOH. So CNV, and I want to find this question mark over here. So I don't know this N, but I know at neutralization, the volume of HCl is 30 and the volume of NaOH is 20. So I can fill this up. So HCl is 30 over 1000, and then this one is 20 over 1000. So I'll first find out HCl. So HCl is C equals to N over V. So N equals to C times V. So that's 2 times 30 over 1000. Alright. because the mole ratio here is 1:1, so this is also the number of moles of NaOH. So 2 times 30 over 1000. So in order to find out what is the concentration of NaOH, I need to have C equals to N over V. So equals to 60 over 1000 divided by 20 over 1000. Right? And then that would be equals to 3. Okay, so I think firstly this question, we must understand that at this point there will be neutralization, right? And therefore this is the volumes that are required for neutralization. Okay, all right, let's take a look. Next one, number 8. The carbohydrate has a formula of CH2O6, and then when it's burnt, excess oxygen and gas is collected. So what we need to all learn is that when a carbohydrate like this is burnt, right, you burnt it with oxygen, and then you will form carbon dioxide and you will form water. Right, so now we need to balance it. On the left side we got 6 carbon, so over here must be 6. On the left side we have 12 hydrogen, so we must also have 6 here. Right, so how to balance this guy eventually, please go and figure out. This one will also be 6. So when they ask you the gas form will be this carbon dioxide. Now the information given in this question is that there is 1 mole of carbohydrates here, and what is the volume of gas over here. So what I need to know is that if there's 1 mole of carbohydrate over here, means that there must be 6 moles of carbohydrate or carbon dioxide over here. And how do I convert 6 moles? So we know that molar volume is 1 mole is equivalent to 24 dm cubed, and carbon dioxide has 6 moles, so that is equivalent to 144 dm cubed. So the answer should be C. Okay, let's look at question number 9. Question number 9 is, I have 50 grams of calcium carbonate and I have hydrochloric acid. So let me write the equation down. Right? You realize we need to write a lot of equation with hydrochloric acid, which is HCl, and this will form calcium carbonate. This is what we learned in lower sec. Right? And then we'll form carbon dioxide and we'll also form water. Carbonate plus acid give me salt, carbon dioxide and water. Alright, so let me check whether this is balanced. So this one over here, this must be 2. Now I have 50 grams of impure calcium carbonate, so that means I got calcium carbonate this amount, and the total is 50 grams. However, there is one portion here that is impure. So the impure part will not react with the hydrochloric acid. Alright, so over here they also tell me that 6 dm cubed of carbon dioxide is formed. So I want to find the percentage purity of the limestone, which is this one. So I want to find out how much is this, right? So we know that I given the 50, but this 50, not all 50 will react. So I need to calculate from the 6 dm cubed backwards. All right, so let's take a look. Let me get out. No, let's. Okay. Oh, there. Okay, so let me do the working here. So we are going to calculate what is basically the first step. The first step is that we are going to calculate the number of moles of CO2. Right? So we're going to calculate how many moles of CO2 is there. Then the second step is that using mole ratio, I'll find out the number of moles of calcium carbonate that reacted. That means this is the number of moles of pure calcium carbonate. And then the third step, I can find the mass of calcium carbonate. Alright, okay, so let's start. So if 1 mole is equivalent to 24 dm cubed, 24 dm cubed. Right, if 1 mole is equivalent to 24 dm cubed, then 6 dm cubed, right, has to be less than 1 mole, right? So it's 6 divided by 24, okay, because, yeah, so and that is 1 over 4, so 0.25 mole. So based on mole ratio, this is 1:1. So the number of moles of calcium carbonate that reacted is 0.25 mole. Now, then I can find the mass of calcium carbonate that reacted. So this is step number 3. So the mass of calcium carbonate that reacted is equals to 0.25 mole times the MR, which is 40 plus 12 plus 48. Right? And that will be equivalent to 600 lah. So this is 25 grams of calcium carbonate has reacted. So if 25 grams of calcium carbonate has reacted and the whole calcium carbonate is 50 grams, the percentage purity of calcium carbonate will therefore be 50%. So the answer here is B. Alright, okay, next. Alright, so now we are at question 10. Now question 10 has quite a lot of information that you haven't really learned before, but let's try to do this, okay? So what we have here is copper 2 sulfate, which is like this, the formula, CuSO4, and this is blue color. Alright, sodium carbonate is Na2CO3, and this one is white color. So when we mix this together, the ratio is 1 calcium sulfate will react with 1 sodium carbonate. Okay, that's what you need to know. You react 1:1, and it will form copper carbonate, and this one is green. Okay, so that's what you need to know. 1:1, and the product is green. Right, the product is green. Let me put it over here. Right, so now we are given 4 cm³ of equals copper sulfate and 8, and you realize that the concentrations are the same. Right, because the concentrations are the same, I can just compare the volume. So I have 4 cm³ here. So if I have 4 cm³, I will need also 4 cm³. However, I have actually more than that. I have 8 cm³. Now this is although a white powder, but this will form a colorless solution. Okay, I forgot to tell you that. This form colorless solution, colorless solution. Okay, and then this one is a blue solution. So what you have noticed is that this guy is excess, right? So we have colorless solution excess, and this one we are limiting. So we don't have any more blue color. Alright, so but we will produce this green color, which is a green precipitate. Okay, precipitate, I'm sure you have learned in lower sec, it means a solid. So we definitely have produced a green precipitate, so it's either B and C, but now it's whether it's going to be a blue solution or colorless solution. If there's a blue solution, it would mean that there's copper sulfate left. However, because copper sulfate is limiting, we know that there's no more copper sulfate. Colorless solution, it will mean that we have sodium carbonate left, right? And because sodium carbonate is excess, we know that sodium carbonate, there's extra. So therefore, there is sodium carbonate left and there is copper carbonate inside. So this would be C. Alright, next. This one, we really need to remember your lower sec. So over here, sulfuric acid is H2SO4, and I am reacting Mg with H2SO4. Metal plus acid gives me salt and hydrogen. So MgSO4 plus H2. Do I need to balance this? No, nicely balanced. Next one, MgO. This is alkali plus sulfuric acid will give me also salt MgSO4 plus H2O. Need balance? Don't need. Magnesium carbonate MgCO3 plus H2SO4. It gives me MgSO4 plus carbon dioxide plus water. Need to balance? Don't need. So you realize that actually all of the magnesium thing is 1:1, 1:1, and 1:1. So I'm given 12 grams of magnesium, 2 grams of magnesium oxide and 4.2 grams of magnesium carbonate. So we need to calculate what's the mole. So magnesium 1.2 grams is actually 1.2 divided by 24. 24 is the MR of magnesium oxide. What about magnesium? Oh, magnesium, sorry. What about the magnesium oxide? What's the MR? So MR of magnesium oxide is 24 plus 16. So that is 2.0 divided by 40. What about magnesium carbonate? Magnesium carbonate is 24 plus 12 plus 48, which is 16 times 3. That will be equals to 84. Right? So, and then that will be 4.2 divided by 84. So I think you should be able to see that 1.2 divided by 24, 2.0 divided by 40, and 4.2 divided by 84 is all the same number. Right? They are all the same number. I hope you can see that. Okay? So therefore, which statement is correct? Is that if all of the number of moles, this is the same number of moles as this, is the same number of moles as this, so all of the moles of magnesium sulfate produced is exactly the same. So the answer here is D. Okay? Great. Let's go to the next question, 13. So the reaction of ethanol, which is 23 grams, with excess hydrogen bromide, the mass of bromoethane, which is this one here, is 27 grams. Now I want to find the percentage yield of bromoethane. So percentage yield is of this guy here. So what is happening here is that I am assuming I start with 23 grams of pure ethanol. So percentage yield is looking at the product. So I need to first find out what is the theoretical yield. So percentage yield is actual yield, right, divided by theoretical yield times 100%. So the actual yield is this one. Okay, actual yield, they say I obtained 27 grams. So this is the actual yield. So theoretical yield, this one I need to calculate. And theoretical yield, I can start from 23. So what do? I was first divide into 3 sections, right? Okay, let me take out another sticky note. Okay. Oh no. Okay, so I divide into 3 sections. Divide into 3 sections. Alright, so firstly, I will need to find out what is the number of moles of ethanol. So that is equals to the mass, 23, divided by the MR, which is here, 46. And I believe this is 0.5 moles. Okay, after that, I need to use mole ratio. So this is 1 is to 1. So the number of moles of C2H5Br is also equals to 0.5 moles. Right, mole ratio. Then I need to find out what's the theoretical yield. So the mass of C2H5Br is equals to the number of moles times MR, which is 109. So I believe this would be 54.5 grams. Right? So the theoretical yield is 54.5 grams, but in this reaction, only 27 grams come out. So what is the yield of this reaction? So it's 27 divided by 54.5 times 100. And you may notice, wow, it's a very nice number. That is 50% yield. Okay, so the answer here is B. Okay, all right, question number 14. Question number 14, and 42 grams of hydrogen carbonate, so I write immediately 42 grams, was heated strongly. 3 dm cube of carbon dioxide was produced. Now, percentage yield of carbon dioxide, so percentage yield refers to the product. So, like what we did previously, we need to go and see what is the theoretical yield, and then we go and calculate. So I remind all of us again, right? remind all of us again, percentage yield is equals to actual yield, the thing that I actually get, divide by theoretical yield times 100%. And the actual yield is given here, 3 dm cube. Theoretical yield, I need to go and calculate. Alright, let me highlight in a different color. This one, I need to go and calculate. Alright, so how do I calculate? Divide it by 3. I need to first find the number of moles of sodium hydrogen carbonate. Right? And then after that, I need to do mole ratio to find the number of moles of carbon dioxide. And because I given volume, so lastly I need to find the theoretical volume of carbon dioxide. So the number of moles of sodium hydrocarbonate is 42 divided by the MR, and the MR is given here, 84. So divided by 84, just nice number, 0.5 moles. The mole ratio is 2:1, so it is 2 NaHCO3 is to 1 CO2, so that is 0.5 is to 0.25. So I know that the number of moles is 0.25, so the volume is 0.25 moles times the molar volume, which is 24 dm cube, that would be 6 dm cube. So I'm supposed to produce 6 dm cube of carbon dioxide, but I only produce 3 dm cube. So it will be 3 divided by 6 times 100, and that would be 50%. Okay? Simple enough, right? B. Okay, great. Let's look at the next question. The next question would be question number 18. Now we have calcium, iron, magnesium, and zinc were reacted with hydrochloric acid. So over here, they are all metals. So we have calcium. Let me write out equation for you. Calcium is Ca, iron is Fe, magnesium is Mg, and zinc is Zn. So they all react with HCl. Right? They all react with HCl, and they will all produce salt plus hydrogen gas. So the reason why they chose these metals is because all of these metals will all form a 2+ charge. They will all be 2+, so the mole ratio of metal to gas will always be the same. It's always 1:1. Okay? So they use 1 gram of each. So let's say the MR of the metal is X. So MR of metal is equals to X, right? And we all start with 1 gram. So what is the volume of gas formed? The volume of gas formed would therefore be 1 gram divided by the MR, which is X, right? And since the mole ratio is 1:1, you will times the volume, which is 24. So for all of the, right, this is the volume for all of the gases. And you realize that it will be the same equation for all 4 metals. Now, the metal that produced the largest volume of gas, for this number to be the biggest, this is 1 times 24 over X is 24 divided by X. For this number to be the biggest, X needs to be the smallest. That means this question is asking you not about which metal produced the greatest volume of gas, but the question is asking you which metal has lowest molar mass. That's the question over here. So if you consult your periodic table, I believe the answer should be magnesium. Right? Magnesium have a molar mass of 24. Iron should be, I think, 56. Calcium is 40. Zinc, please correct me if I'm wrong, which I most likely be wrong, it's 63, I think, cannot remember, 63 or 64. Alright, so the answer here is magnesium. Okay, so please learn how to interpret the question properly. Alright, now let's look at question number 19. Question number 19, sodium hydroxide reacts with sulfuric acid, and then they give you the volume of sodium hydroxide and then the solution of sulfuric acid. So what volume will react with this mass of sulfuric acid? So now when you see this equation, you all should know that immediately I must write this. right? C, N, and V. Okay, I am given sodium hydroxide concentration 0.2, and I want to find the volume here. And the answer is all in cm cube. Okay, but eventually this one must be in dm cube, right? Okay, so what about sulfuric acid? Unfortunately, for sulfuric acid, I cannot do C, N, and V because I am given mass. So I just need to calculate what's the mass, the number of moles of sulfuric acid. So number of moles of sulfuric acid is just mass, which is 0.49 grams, divided by the MR of sulfuric acid, which is 98. Alright, which is 98. So my math is not so good, so let me take this out. 0.49 divided by 98, 0.005. So the number of moles of sulfur is 0.005 moles. Alright, now I know that this is 0.005 moles. I know that the ratio is 2:1. So if it's 0.005 moles, that is 1. The 2 would be 0.01 mole. So I can fill this one up, 0.01 mole. Now you got the usual C equals to N over V format. C equals to N over V. I want to find V. So V is equals to N over C. So V equals to N over C is 0.01 divided by 0.2. Right? And again, math cannot. So what is it now? 0.01 divided by 0.2. 0.01 divided by 0.2, and that's equals to 0.05. 0.05, and this is in dm cube, and then you times 1,000. Sorry, you times 1,000, and that will be 50 cm cube. Okay, answer here is C. Next, all right. So bromobutane. Oh, this looks very familiar. So 10 grams of butanol produces 12 grams of bromobutane, and I want to find percentage yield. So we have done this many times before already. So again, percentage yield is equivalent to actual yield divided by theoretical yield. Actual yield is this 12 grams over here, so I need to find out what's the theoretical yield. So first I find the number of moles of butanol, which is this one, is equals to 10 grams divided by MR, given over here, 74. Okay, I'm just going to leave it in fraction because this one is a multiple choice question. So the ratio is 1:1. So the number of moles of bromobutane is equals to 10 over 74. Again, I'm leaving it in fraction because this is a multiple choice question. No one's marking me for working. So then I need to find the mass of C4H9Br, and that will be equals to number of moles times the MR. And nope, 10 divided by 74 divided by 137. 10 divided by 74 times 137. So 18.5. So the theoretical mass is 18.5, but I only got 12. So that will be 12 divided by 18.5 times 100%. Calculator again, 12 divided by 18.5 times 100%. So that will be 65%. So the answer here is C. Alright, so the next one I believe you all should be able to handle. This is limiting reactant. So what they're trying to tell you is that the 2.4 react exactly. So that means no leftover. Everything finished to give me 2.4. So now I want 4.8. That means everything must sort of times 2. So if I do this, it will not times 2 because I don't have enough of this. Right? So this one is wrong. Over here, what times 2? The volume here. So if only 1 times 2, not enough. So also cannot. Right? Because 2.4 grams react exactly with this. So if I want to get twice, I need to increase times 2 of this. I also need times 2 of this. So this 2 cannot. So I only left with this 2, and this one must times 2. So this one compared to my original is the same. So cannot. And then I must times 2 over here, right? So I'm getting a more concentrated, same volume. So the answer is D. Okay? All right. Let's look at the last one. So the last one shows the enthalpy change of combustion, and this is kilojoules per mole. That means if I combust 1 mole of hydrogen, I produce 286 kilojoules. So I'm going to write here 1 mole of hydrogen produce 286 kilojoules. 1 mole of methane produce 889 kilojoules, and so on. Okay? So octane, let's look at the first one. So we're supposed to see which one is correct. So let's go at the first one. Octane produce more heat than hydrogen for each gram of fuel. So what do I need to know is that if 1 mole produces this amount of energy, right? I need to find 1 gram produces how much. So how do I find that out? So I know that 1 mole of hydrogen, right? 1 mole of hydrogen, the molar mass of hydrogen is 2, right? H2. So instead of saying 1 mole, I can say 2 grams of hydrogen produces 286. For methane, the molar mass is 16. So instead of saying 1 mole, I can say 16 grams of methane produces 889. Now for octane, the molar mass is 8 times 12 plus 18. 96 plus 18 is 114. So we can say that instead of saying 1 mole produces 530, I can say 114 grams. Let me double check. 8 times 12 plus 18, 114. Okay, so 2 grams of hydrogen produce 286. 16 grams of methane produce 889, and 114 grams of octane produce 530. So we need to go and find out per gram. So if 2 grams produce 286, 1 gram of hydrogen will produce 143. I hope you can get that easily. If, let's move this to the side since I need to do some calculation. Right, if 16 grams produce 889, 1 gram will produce 55.6. And if 114 grams produce 5330, so 5330 divided by 114 will produce 46.8 kilojoules. So now the statement says that octane produces more heat than hydrogen and methane per gram. So is that true? 1 gram of hydrogen produce 143, 1 gram of methane produce 55.6, and 1 gram of octane produce 46.8. So this statement is not true. Okay, next one. On complete combustion, 1 gram of hydrogen produce 286. So let's look at it. Is that true? That is not true, because 1 gram of hydrogen produces 143. This is not true. Last one, methane is completely combusted. The energy required for both. Okay, this one is next chapter, not next chapter, Sec 4 chapter. So you already know that 1 and 2 is wrong, so this one cannot. 2 is wrong, so the only remaining answer will be D. So I think at Sec 3 level, this is a good enough answer. Alright, so I hope that will be fine. All the best.